So today I'm going to show you how to use Clarinet. Clarinet is a really, really awesome tool that was written by Ludo for doing local Clarity development and testing. So if you look at my screen here on the left side, we have a very simple Clarity contract. And on the right side, we have my terminal. And I'm in a directory called Billboard. That's the name of this contract. And if we look in here, we can see that there are a couple folders and a couple files. We have a folder called contracts. If we look inside there, we can see that there are a couple of contracts. This is just kind of for the purpose of this demo. They're really the same contract that kind of just build on each other. So we're going to start with Billboard 1. And then additionally, if we look in the tests directory, similarly, we have a test file for each of our contracts. I was able to create this directory by simply running Clarinet new and then the name of the project. And it automatically kind of creates this project scaffolding and sets everything up for you. However, when you do Clarinet new for the first time, your contracts and tests folders are empty. And so you can create new contracts by typing Clarinet new, it's Clarinet contract new, and then the name of the contract, like that. Okay, and then the last file in here worth looking at is this clarinet.toml. This is automatically generated for you by the Clarinet commands. However, if you need to, you can obviously manually tweak it. And we can see that this simply just looks like this. So it has some information about the name of the project, and then each contract has its own fields. So it's like the path to the contract and then contract dependencies. And this is a pretty simple contract we're going to be working through today. So there aren't any dependencies, but that's kind of like something we can get into later, maybe. Okay, let's begin. So the contract we're going to be talking about today is called Billboard. And Billboard is simply a contract that lets users display a piece of text on a website. And we're not going to be working on the website portion of this today, so you'll have to use your imagination as to what this could look like. But instead, we're going to be focusing on the smart contract, which actually is the logic behind this application and kind of lets people actually change the state. So if we look at this contract, we can see that it's kind of divided into a few pieces. We have functions at the bottom. We have a data variable called Billboard message, which we can see the type of it is string UTF-8. And then this number is the maximum length of the string. So when you're creating strings in Clarity, you have to specify their maximum length. And then this is the default value of the data var. So this is what it starts at. And then we have some error codes up here. So this is just a constant that maps to an error code. And so if we go back to the terminal, I can type Clarinet check, and we can see that nothing gets output. But for example, if I were to maybe leave out this number here, or actually let's just remove this parenthesis, this would be an invalid contract. We do Clarinet check. We can see it tells us about the syntax error, parsing error, list expression, left opened. So that's this missing parenthesis right here. So Clarinet check, it's a really useful command that you're probably going to run all the time when you're developing Clarity contracts, just to check for syntax errors. And you'll probably, I think somebody's got their mic on. Okay. Anyway, so yeah, you'll find yourself using Clarinet check all the time, I imagine, especially towards the beginning of your journey developing in Clarity, just because the Lisp syntax with all these parentheses can be a little bit hard to manage sometimes. But luckily, Clarinet check will always notify you if you have a syntax error. So then, yeah, moving further down this function, we can see we have two functions, just a getter and a setter. And the getter simply returns the data var that we've defined here, Billboard message. And we can see the contents calls this var get function. That just gets the contents of the data var. And then it wraps it using the OK function. And so what the OK function does is it takes the value and it constructs a response type. A response is simply a type that can either be OK or error. And every public function in Clarity has to return a response. So this is kind of really nice if you're developing against a contract because you know exactly what you're expecting for the return type for any of these public functions to be. You always basically have to check if the response that you get back is okay or if it's an error. So it kind of forces the contract developer to be kind of like upfront about when things go wrong. But in this case, nothing can really go wrong here. We're kind of hard coding the name of the variable, so there's no uncertainty there. So we're simply just going to wrap it in this okay value. In fact, actually, I'm realizing now this is silly. This should really be defined as a read-only function because it's not actually changing any state. So we can define it like this, and we can simply just return the value. This is another kind of function in Clarity, these read-only functions. And if you don't actually change any state in your function, if it's just reading data, this is the kind of function that you want to use. It's less, it's just more optimized for this kind of operation. So we'll do another Clarinet check, make sure that this is okay. Excellent. Our set function is a public function because the set function is actually going to change some state. And we can see the argument is message, and it takes a string of the same type as our billboard message. It's worth noting that there are two string types in Clarity. There's a UTF-8 string and an ASCII string. We're going with a slightly larger UTF-8 string here because maybe people want to include, emoji characters in their message. But if you don't think that that's necessary, maybe it would be worth considering the ASCII string. This is kind of you'll notice Clarity gives you a lot of power over like really trying to optimize for like efficiency and kind of minimizing runtime cost. Again, this is just because every operation in Clarity has a cost associated with it. So wherever possible, you want to kind of take the least expensive option. And this function simply is basically just a wrapper around this varset Clarity function. And varset lets you set the value of a data variable. So we set it to the message. And then I'm using an if statement here to simply check if the results, the return value of varset is okay. Varset returns a Boolean, either true or false. So I'm saying if varset returns true, which means that it worked, then we return okay, true. And if it returned false, then we return okay, we return an error with our error code that we created up top here, which is just going to return U0. And ideally, kind of the client application that's communicating with this contract will know how to interpret that error. I think this would really only fail if your message is too long or if it contains invalid characters or something like that. So let's actually poke around with this contract. So another really useful Clarity or Clarinet command in the command line here is we can say Clarinet console. And this is going to open up a REPL. And a REPL just kind of lets us actually like interact with the contract functions. So we can see that it's a little bit small. Let me make this bigger. So we can see that there are like 3 contracts loaded, and these are the other 2 that I've written that we'll get into later, but simply focus on billboard 1. So we can see billboard 1, public functions, get message, and set message, and we have the type signatures of these functions. Additionally, Clarinet initializes 10 addresses, the first one being the deployer address, and then we have 9 wallets that we can play around with in our tests and using the console to actually test out and interact with our contract. The default state, I believe, is, I think we're either in wallet 1 or the deployer. Ludo could maybe mention which of those is true in the chat. I think we could type like tx sender here, and maybe that's okay. So anyway, so we can mess around with this contract by using the contract call Clarity function, and the contract call function takes the name of the contract, which in this case is Billboard 1. And so we can use kind of the like not fully qualified name because it was deployed by the same context that we're in, I believe. And then this will take the name of the function we want to call. So maybe let's start with get message. And then we would list any arguments, but this function doesn't take any arguments. So press enter, and we can see it returns hello world because that is what we initialized this data var to be. And this function simply returns the data var. So now let's try actually setting the message. So we'll call the set message function. And we will give it a string, and it's a UTF-8 string, so it gets prefixed with a U. And we can say testing. And that returns okay, true. So we know that that went well. And now we can do get message again. And there we go. We get our new updated message. So yeah, this is kind of like a very, very simple contract, and we can see that it works. But maybe you want, maybe you don't want to have to like, use the console every time something changes to verify that your function still works. So you can actually use this test harness that's included with Clarinet. And so this test harness is it uses the Dino runtime, which is very similar to Node, and the code here is written in JavaScript. And so we can create tests simply by calling the clarinet.test function. We're bringing in Clarinet from the Clarinet kind of JavaScript or Dino repository. And we pass in this object that has the name of the test. So we could say ensure that setting and getting message works. And then we pass in a function. And this function takes, the function here takes a chain and accounts, which gets kind of automatically filled in by Clarinet. So we can access these things in our test. And so the first thing I'm going to do in this test is I'm going to get the address, or I'm going to get the wallet1 object from the accounts map that gets passed in here. And so this will actually let us access this address for the purpose of making contract calls. Then I'm going to call chain.mineBlock. And mineBlock kind of simulates mining a block on the blockchain. So we can, in this block, we can include a bunch of different transactions. And here I'm including 3 transactions. The first one is simply a contract call to the get message function. So we provide the name of the contract, we provide the name of the function, then we provide arguments, and this function doesn't take any arguments. And then finally, we provide the sender address for the transaction. And here we're going to use wallet1. Again, this is one of the wallets that Clarinet sets up for us for the purpose of writing these tests. The second call will be to set message. And the only difference here really is the name. And here we're providing some arguments. And so just a single argument here. We're using the UTF-8 function from that we get from by importing types. And this function simply makes it really easy to construct a UTF-8 string from a normal JavaScript string. And then finally, again, we're giving the same wallet. And then this last call is just another call to get message. And so what this lets us do is write some assertions about what actually happened here. So when we run Clarinet test, it's going to run this code, simulate the block, make these contract calls. And then at the end of this, we can check that the state is correct and what we would expect. And you can mine multiple blocks or simulate mining multiple blocks in a single test. But for this test, it's very simple. We're just going to do one. So the first assertion we're going to make is that there were 3 transactions or 3 receipts that were actually got generated. And this is basically just kind of a simple sanity check. The next one is going to be that the block height is 2. So this is checking that we've mined a block and the height has gone from 1 to 2. Then we're actually going to check kind of the result of our contract calls. So we're going to say block.receipts at index 0. So this is that first get message call. And we want to first expect an OK result, and then we want to expect a UTF-8 string. And again, this is because, actually we can get rid of this because we turned it into a read-only function, which will return the value directly, because initially we had it as a public function. And then, yeah, so this is just checking that the result is hello world initially. And then this second check here is checking that the third contract call, which is our final get message, is expecting the updated string, which in this case is testing. So let's actually run these tests. So Clarinet test. I'm sorry. Oh yeah, I'm still in the console. Clarinet test. Okay, great. So fantastic. So we can see that this first thing is the test we just worked on. Ensure that setting and getting message works. We can see that like if I change this, this will fail. And we can see that it says expected testing and got testing. So yes, it seems like our contract is working as expected. I guess let me pause here before I move on to see if there are any questions. I don't think I can see the chat because I'm presenting, but maybe Joe, does anyone have questions about any of this yet? Actually, you know what? Maybe I'll just keep running through, and we can do questions at the end. I think that'll be easier. Okay, so just to do a quick recap, we've written a basic contract. We've messed around with the contract using Clarinet console, which provides us with a Clarity REPL. And we've written a unit test, or even more of a kind of pseudo integration test for our contract. And to do all of this, we didn't actually have to interact with any of the Stacks networks. We didn't have to use testnet. We didn't have to use a mocknet. Clarinet kind of takes care of all of this for us. Okay, so let's move on. So let's make the contract a little bit more interesting. So this iteration of the contract introduces a price for updating the billboard message. So now we're actually charging people to update this message. And so we can see we have a new data var here called price. And initially we're setting it to 100. And this value is going to be in microstacks, which is, I believe, I think a millionth of a stack. So you have to do a little bit of math here when you're thinking about the numbers in these smart contracts. But anyway, this is very small, but you could set this to be whatever you want it to be. We still have our get price function, which actually I'm going to replace with the read-only version. Cool. And then we have, and we don't need this. And then we have an updated version of our set message function. And so the set message function, if we kind of compare it to the old one, I'm just going to flip back to the old one. The old one simply had an if statement. It set something, and then if the set worked, it returns true. If it didn't work, it returned an error. We can see that the if statement's still there, but now everything is contained within this begin block. And the begin function is a really important function in Clarity. So if you've kind of noticed as we've been programming in Clarity, Clarity is like a functional language. Every single thing that we are writing in Clarity is a function call. And if you're into functional languages or you've programmed in this style before, you'll kind of recognize this language as being very, very similar to Lisp or Scheme or any Lisp variant. And so in this style of language, it's not that intuitive to kind of sequence events or like make multiple calls that maybe alter state in a row. So the paradigm for doing that kind of thing in Clarity is by using the begin function. And the begin function simply lets you pass in multiple other function calls. So it'll kind of execute them sequentially, and then it will return the value of the last one. So we can see here, we say begin, and then we say we have this STX transfer function call, which is wrapped inside of an unwrap function call. And I'll talk about unwrap in a second. But if we just look at the STX transfer, we can see it's saying STX transfer. It's getting the current price of the message that, again, is just this data var that we've instantiated to be 100. And then it's saying to transfer from TX sender. TX sender is a keyword in Clarity that will get the it'll get the principal of the transaction sender. So that's the person trying to set the message in this case. And then it will, so it's transfer, it's from the sender to, and then you can see we have TX sender passed into this AsContract function. The AsContract function is also really important and is something you'll probably use a lot. It changes the context from, it changes the context of like what's happening to be the contract address. So basically anything contained inside this AsContract, it's as if it's from the perspective of the contract itself. So when we wrap TX sender in the AsContract function, the value, instead of being the the sender of the transaction, is actually now the contract's address, because the contract is now we're now kind of viewing things from the perspective of the contract. It's a little bit confusing, but this is kind of the way to get the contract that we're kind of like wherever this gets deployed to, the contract's address. And there are certain other like use cases for this. For example, if you want to transfer stacks from the contract to someone else, you would do that using this AsContract function, and you'd put the STX transfer inside the AsContract function. Okay, so that's the STX transfer function. So this is going to attempt to transfer stacks. And I say attempt because, this might not work. Like maybe TX sender doesn't have enough stacks in their wallet. This question mark at the end of the function name kind of indicates that this function might fail. And it also kind of tells us that this function is going to return something of the response type. So it's either going to be okay, or it's going to be an error. And this is really useful, when programming in Clarity, because it kind of immediately tells us, okay, we're going to actually have to handle the failure case of this function. So we do that by using this unwrap statement. And so the unwrap function, will attempt to, it'll basically like look at the value returned by STX transfer. If it's an okay value, it'll return the value contained inside the okay value. If it's an error value, it will throw the error that we pass in here. So if STX transfer errors, unwrap will also error, but it will error with whatever error we want to give it. It'll return whatever value we want it to return. And most of the time, you're going to want to pass in an error value, because usually this is when something goes wrong. And so we just created another error constant, error STX transfer. I gave it another kind of unique value, an error code. And we are going to return it if something fails here. The second function, the second Clarity bit of Clarity code that we're passing into the begin function here is the if statement from before, and this is unmodified. And something you'll notice about this if statement is that the return values kind of match, or the error value matches the error type that is going to be returned from unwrap. So like, the function or the return values of our Clarity functions have to be consistent. If we were to change this, like if we didn't return an error here, for example, and we did a Clarity check, it would complain, Clarinet check, it would complain to us, telling us that, we have like one arm of our function that is trying to return potentially going to return a uint, and then we have another part that might return a response bool uint, right? So that means that we need to make this a response bool uint, and we can do that by wrapping it in the error type like we had before. And now this will type check. Okay, so let's go back to our, if we go now to our second test. This is kind of an updated test for this new kind of updated function. And so we can see that it's a slightly simpler test. We don't bother with the initial get message. I'm simply trying to set the message and then get the message. But I'm doing something else here. And what that is I'm getting the asset map from the chain object. The asset map is simply just kind of like a list of accounts and balances. So it lets us check, if an account balance has changed in our test. And we are expecting the sender's account balance to change here because they have to transfer stacks to actually call this function. So we're going to get the initial balance by saying asset maps, assets, STX, and then passing in the wallet's address. And then we're going to do the contract call with the wallet's address as well. And then we're going to get the message. And we're going to check that this message is correct. So we're checking that the resulting value is testing, which is what we're trying to change the message to. But we're also asserting that the account balance is equal to our starting balance minus 100, because 100 is the cost of, or is the price of setting the message here. And we'll do Clarinet test. And it's, I see. Oh, I think this is just a problem with, let's see. I think this just has to do with something that I changed since updating this. But anyway, this should work and it's not working, but you kind of get the idea. Let's see. Anyway, I guess it wants, oh yeah, okay, I'm sorry. I should do expect okay here because this function does actually return what's the problem? All right, let's just move on here. There's some minor error in this test, but I think it gets the point across that you can use Clarinet to check that account balances have changed, and you can use Clarity contracts to actually transfer the value or transfer stacks from one address to another, and transfer fungible tokens and non-fungible tokens in kind of a similar way. The final incarnation of this Clarity contract simply introduces kind of another important Clarity construct, which is the let function. So if we go back to the second version, you can see that we're saying var get price, right? But there might be examples where we want to use price more than once in the body of this function. Maybe we actually want to increment price in this function, right? So we don't necessarily want to have to get the value of price for every time we want to use it, because that would be kind of redundant. So we can actually create local variables that we can use in the scope of our clarity function. And we do that using this let function. And let simply takes a list. The first argument is a list of variable names and then values. And so we're saying, let's create a variable called current price, and then let's bind it to the result of var get price. And then we can use it in the body of let. So aside from this, let kind of works like begin, but it lets us create variables that we can use in the body. So for example, now we could do something like, after this STX transfer happens, we could say varset price, and then we could set it to be current price plus, sorry, I've already got the plus 10. So this will increment the price anytime somebody sets the message, making it more expensive to set the message as time goes on. And yeah, similarly, you can kind of now, you could write a test against this that would test that the value of price is going up as people are calling this function. Awesome. So I'm going to stop sharing. And I'm assuming there are a bunch of questions about this. So yeah, let's just open it up for questions that Ludo and I can answer about this demo or Clarinet kind of more broadly. Yeah, does anybody have questions? Let's look in the chat here.
Would you explain again as a contract?
I'm sorry, can you repeat that? I couldn't hear you.
Explain again as a contract, what it does, what is the final value it puts there as contract.
I'm having a bit of trouble hearing you. Are you asking for clarity about the begin function? Is that what I'm hearing?
Reed, I think he's asking about the AsContract function. So when you say AsContract TX sender, can you explain that a little bit more?
Yeah, absolutely. So the AsContract function basically switches the current context's TX sender value to the contract's principal. And additionally, it executes an expression with that context. So it's useful for being able to get the contract principal. So if you need to do something like kind of from the perspective of the contract, maybe you want to transfer value from the contract to someone else, you need to use the AsContract function. Otherwise, the contract doesn't really have like permission to kind of do that. I can link to there's a whole section of the docs about this function that I'll put in the chat right now. Any other questions? I see, is there a GitHub link to this demo? There currently is not a GitHub link to this demo. I'd be happy to push this to GitHub, but I will say that it's very similar to some of the sample code that Ludo has provided in the Clarinet repo. So if you go in the Clarinet repo, I believe there is an examples directory, and you can see a bunch of examples of how to actually structure and use Clarinet to write Clarity contracts. Okay, I see a question that says, we did begin, and then we deducted the balance, and then we set the message. And so it says, what happens if set message fails? That's a very good observation. I think in that case, we would probably want to kind of undo the balance deduction. It's a bit tricky because, in a Clarity contract, you're right, there are multiple moments where things can fail. Ideally, we don't want to set the message before deducting the balance, because then, then if the STX transfer doesn't work, then they've set the message for free. So at some point, we're going to have to do some checking and maybe reverting to a previous value if we really want to be super safe in this contract. So yeah, that's a good question, and you kind of have to like program with those edge cases in mind, which we did not do in in this very simple example. But yes. And then someone was asking about match statements. Oh, it looks like Ludo answered a bunch of the questions in the chat. Does anybody else have any questions that they haven't asked in the chat?
I have a quick question.
Sure.
I was just wondering if in the stacks transfer, whether you can pass through the error that the stacks transfer throws rather than wrapping it and sending a new error back.
Yeah, so you could just return the error that the STX transfer throws. Like maybe you don't even, if you just totally omit the unwrap statement, and that's kind of the last function call in your function, you could totally do that. I'd be curious to hear what Ludo has to say about this, but I'm kind of under the impression that it's like a good idea to have like contract specific error codes that you and people developing against your contract can reference kind of to understand, what exactly went wrong in your contract, because, like it's just better to kind of have like one scheme with like one list of error codes that are all kind of like related to each other, I guess, rather than like throwing an underlying clarity error, which might not make sense in the context of your contract. So as the contract developer, I think you should kind of be aware of like what the error that might get thrown is from the clarity language. But then I would kind of suggest wrapping it in your own error and, providing context via like documentation or comments or something as to what your error means. Ludo, do you have any thoughts about kind of best practices with error handling, I guess?
Yeah, can you hear me?
Yeah.
There's a lot of noise, sorry. Yeah, I think what you said makes sense. With maybe a nuance, sorry. I think that in the context of traits, maybe you want to like just use the error coming from like the native code and just return whatever the native function is returning, so that like every token is is using the same error code. But yeah, I think it makes sense.
Cool. That makes sense.
I have a quick comment on this as well, like specifically for Stacks Transfer, that function. I've been using that quite often, and there's 4 different errors generally. And I feel like for the end user, it could get confusing if you return one generic error and, for instance, show that in your front that, right, transfer failed. That doesn't really say much, and I think that's obviously why you have the U1, U2, U3, U4.
Yeah.
But I think if you would catch those and maybe forward those either in the same or another format, you could do that. But maybe, read yourself, or maybe Ludo, you could comment on this. Can't you use the match statement for this as well? So you wrap Stacks Transfer match, which returns the exact error code.
Yeah, absolutely. Yeah, right. That would definitely be the more prudent way to deal with this. And in a slightly more comprehensive demo, I think is how I would have gone about it. You'd use the match statement, catch all of the various different errors that could be returned, and potentially wrap them in your own errors if you don't just want to, directly return one of the STX transfer errors.
Awesome.
Yeah, Michael says would love to see that example. Yeah, we can maybe send out a follow-up with that example. Any other questions about Clarinet, testing clarity, how to kind of develop locally? Anything?
Speak now or forever hold your peace.
Michael asks, can we go through an NFT example at some point? I don't know, Patrick, can we?
Yeah, so tomorrow we're going to be talking through both the NFT and the fungible token standards on Stacks. That's going to be with Jude and Preager. Tomorrow morning we'll be talking a lot more about those specific examples.
Sweet. Alex asks, when will Clarinet check be real-time and visually represented in the IDE?
I think that's a Ludo question.
Yeah, it's maybe more of a Ludo question.
Yes, so if you only have one contract, then you can use the Clarity LSP that will do exactly that. So it will like check when you save your contract and highlight in Visual Studio, the error path. So that's already possible. But we still need to augment the LSP with Clarinet, which will give you the ability to deal with multiple contracts and contract call and traits and stuff like that. So it's a work in progress. But if you only have one contract, you can use the Clarity LSP extension that you can find on the Visual Studio Marketplace.
There's a question about the Clarity plugin and if there is an IntelliJ JetBrains version. Unfortunately, no, we only have a VS Code plugin right now.
There's a question that's come up twice, and sorry we missed it, about why the assert test has to be wrapped in an async function.
So at the moment, all the interaction with the chain are synchronous, but I did wrap everything in an async function so that you can like call some await functions like without wrapping it. So it's more like a future-proof concern versus anything else.
Any other questions?
I want to ask a question about begin.
Sure.
So if I have several operations that one of them might fail, and I want to run them as a sequential bulk, I would use begin. Is that accurate?
You said you want to run them as a what?
So I have this many operations that depend on each other.
Yeah.
And some way, one of this operation might fail. So to guarantee that the final result is what I intended, I use begin around them. Is that correct?
Yeah. Yes. You would use begin if you want to basically sequence function calls. So if you want to do like begin kind of like is a function in Clarity that lets you kind of like basically pretend like you're programming in a more imperative language. So it lets you kind of sequence events that potentially have side effects, which is, you know, not the most functional of language properties, but it is something that we have in Clarity. You know, you can set data variables and data maps, and you can change the state of a contract. And yeah, you asked about like error handling in begin. Yeah, begin lets you, you know, if you use the unwrap function, or, you know, you just call a function that, yeah, I guess if you use unwrap, it will kind of like short circuit the begin function and let you throw an error right in the middle of it. I think does that answer your question?
Yeah, thanks. It's like moving from the functional programming to imperative normal style.
Yeah.
So another question, if I may. What is the difference between the exclamation mark? I have noticed that some functions have ended with exclamation mark and others with question mark. What is the difference between exclamation and question mark?
Right. So okay. So the functions that have a question mark at the end, basically that just denotes that the function is going to return it's going to return something of the response type. So it kind of indicates that the function might return an error. And the way that errors are represented in Clarity is through types like response, or potentially you could think of the optional type as representing, you know, something not working, but maybe not necessarily an error. It's just the lack of a value. So whenever you write a function or something can go wrong, it's good to return something of the response type. And so all of the functions that have these exclamation marks return something of type response. The questions that have the exclamation mark, those questions basically like, what would you call those? Those kind of like let you Ludo, how would you describe the exclamation point? Does that kind of like let you unpack like optional values? Usually, I'm having trouble kind of describing broadly what those do, but they're typically used to deal with.
They basically help you interrupt the control flow.
Oh, right.
Yeah.
Yeah. So the exclamation point kind of indicates that like, it might kind of throw an error right there and kind of stop and return basically. So yeah, they're useful for dealing with errors and dealing with optional values where you might just want to short circuit the rest of the function if you don't have the value you're expecting, or if an error is returned by something like STX transfer. So it's recommended, or maybe even required, that I think this is actually a requirement, right, Ludo, that you have to use something like unpack for an STX transfer operation, unless it's like the final call in a function or in a begin.
Yes, that's correct.
Yeah. Anyway, you tend to use the exclamation point functions in tandem with the ones that have the question mark at the end of them. I hope that answered your question.
Yeah, kinda. So what I understood, that question mark kinda deal with type responses, but doesn't panic, right? But exclamation mark kind of panic with errors.
I'm not sure I'm hearing you correctly, but
the question mark methods ends with question mark doesn't panic, and exclamation mark.
Oh, I see. Yeah, that's more or less correct. The question mark doesn't panic, and the exclamation mark, I wouldn't really think of it as a panic. It's more of like a short circuit.
Yeah, it's not a panic. Like, we have some specific functions for handling panicking. So it's like unwrap or panic. Panic is a different thing. It's going to interrupt the contract, like wherever you are in your core stack. You have the guarantee that the transaction is aborting now versus bubbling up.
Yeah, panic, exactly. Panic is like a more severe kind of interrupt than what a lot of these exclamation point functions will do. Like the scope of it is, the entire execution of what's happening in your contract versus just the single function that we're looking at. I see there's a question, could we do a microblock example sometime in the future? Yeah, I mean, that's maybe something that can be arranged. Sorry, go ahead.
I can also speak to the microblock thing. We do have some documentation coming for microblocks that should land in the next week or two. That is a shortcoming of our documentation right now, but we promise we'll get some enhancements out for you guys.
Yeah, I think that's a bit more of like an advanced concept too that we could get to later.
I also want to note that, from that perspective too, the app demo tomorrow, Haystack will include sort of an overview of how to read pending transactions off of the chain so that you can react in the front end to transactions that haven't been finalized yet against the chain. That's obviously like a design decision that you and your teams need to come up with about how to handle pending transactions and whether to treat them as sort of final. But we will talk through that tomorrow.